In this example, the task is to find the currents I1, I2, I3. So we begin by applying Kirchhoff's rules, beginning with the junction rule at the junction shown here. So at this junction, we notice that of the three currents, I1 goes into the junction, I2 and I3 both leave the junction. Therefore, I1 equals I2 plus I3, because the junction rule says currents in equals currents going out of the junction. Next, we apply the loop rule, and I'm going to pick an arbitrary point here. So starting at this point, going all the way around and coming back to this point, I'm going to call this loop number 1. So the loop rule for loop number 1, we're going to traverse the 4-volt battery from low to high, and then the 2 ohm resistor in the same direction as the current I2. Therefore, the loop rule will be 4 minus I2 times 2 ohms equal to 0. 4 volts minus I2 times 2 ohms equal to 0, implying that I2 equals 4 divided by 2, which is 2 amps. Next, I'm going to pick another loop starting from this same point, going all the way round, coming back to that point, and I'm going to call that loop number 2. So loop rule for loop number 2, we traverse again the 4-volt battery, the 6 volts, and the 1 ohm resistor. So 4 plus 6 minus I3 times 1 equal to 0. Four plus 6 is 10. I3 times 1 is I3, so we just have I3 equal to 10 amps. Now that we have I2 and I3, if we bring in the junction rule says I1 equals I2 plus I3. Therefore, I1 is equal to 2 amps plus 10 amps, which equals 12 amps. So here's your I2, your I3, and your I1. So I1 is 12 amps, I2 is 2 amps, and I3 is 10